Welcome to the SolOhm update for February 18th, 2016. I spent a lot of time on Monday evening and Tuesday implementing more software. And the first thing I worked on was Soft AP, which I'll explain in a minute. And then I also worked on Websockets. So I have a baby step now for Websockets, and it also does Soft AP as well. So what Soft AP does is the radio has the ability to be a client, so it connects to an AP, an access point, as well as being an access point at the same time. And that's actually really nice, because what you can use for that, when you're in the field, you can take a product out and it will always be an AP unit, and then you can connect to that from your phone or from your laptop and configure its Wi-Fi settings, and then it will connect to the infrastructure's access point, as well as still being an access point. So that's the way it's going to do network configuration. Is it always acts as an access point, and then you can just basically browse to it, the configuration screen, and then connect it to the infrastructure. I'll show you that in a minute over here. The other thing, next thing I got going over here was the Arduino WebSockets. There's a GitHub repository for the official distribution of WebSockets for Arduino. And I downloaded this after I saw that this one was had supported hardware for the ESP8266, which is what we're using. So I'll go ahead and show you that now. I have it running on some hardware, the real board itself. I'll go ahead and turn it on. So in this window up here, it's actually getting connected. So it got connected to address 136 here on my local LAN. And then if I want to browse to that address, brings up a web page, and so you can see that it's actually streaming over real-time data. This is not doing any polling now. This is doing straight WebSockets. So a JSON string comes over the WebSocket, and I just basically put it in this div. The other thing I got going was a Node command line tool for WebSockets as well. So the beauty of WebSockets is that in addition to UDP being broadcast out in multiple consumers, we can also do the same thing through a web interface as well as through WebSockets. So it adds additional flexibility to our connectivity. So I got a little beeping camera over here, and my camera turned off. All right, so I have on my cell phone here, it's a Wi-Fi scanner, and these are all the access points right here. ZBoos are the ones that I have running in the office here. And then I also created this one called SSID, and it is my development one that all my embedded systems connect to. I gave it an SSID of SSID, so that when I check in code at GitHub, it doesn't, I don't use my own internal password for that. Then you can see up here, another access point has showed up called SolOhm-MMCF5026. So this is the currently the board that's running in Soft AP. And so what I'll try to do over here is see if I can do this. I'll go ahead and connect to it on the Wi-Fi settings here. Okay, so you see now I'm connected to it. Now if I go back over to my browser, when you're running in Soft AP mode, the board is always set to 192.168.1.4. So I'll go ahead and hit the thing here. So you can see that so in this scenario here, this cell phone connected directly to the board when the board was running in soft AP mode, and I'm running this WebSockets demo. So I could actually have an interface here to configure the network settings to have the board connect to my infrastructure. But this is giving you an example of how it looks on a cell phone by doing it just this way. So I apologize for the camera problems tonight. I'm really tired. But let's move on. Well, here it is. This is the board that was fabricated at the PCB Fab Express. It actually came from San Jose. It came in today, FedEx, around 11:30 or 12. It looks really good. It did have notches cut out of it. Part of their fast service was they said that they don't want only rectangular boards, but the wind had notched this one. Right there in the high voltage section, there's two big squares, as well as right above there. Those are for the solder lugs, and they definitely did not want to put slots in there in the 2-day turn. That was extra cost as well. So I'm going to have to mount those solder lugs that do have a tab coming off of them somehow into these places. But I'll take care of that. It looks really good. I don't see really any visible problems with it. I started putting parts on it, and you can see that I first put on the power supply and I got it functioning. I did put down the wrong footprint for the connectors, as you know, connectors are the bane of my layout. I just always seem to mess up connectors, but I was able to, I didn't have any of these right angle ones, so I just bent these pins back. I ended up taking those connectors off because they are really difficult to pull the mating part out. It's good for the final product because it won't fall apart in shipping or vibrate loose, but for debugging, it's really difficult to get those connectors apart. Those are JST connectors, so I went in and pulled those off the board, and I just soldered some wires right onto it. The SD card slot itself is I can't get the part for that, so I'll have to change the footprint on that as well. I've got the radio down, I put the push button switches in, I have the I/O port, real-time clock, temperature sensor, as well as the crystal for the real-time clock on the board. I had a heck of a time powering up the radio. There are also power supply problems, and I had some oscillation issues, and I isolated everything down to, I decided to put a tantalum cap on the input for the VCC on the radio, and that thing was causing oscillation on the power supply when the radio would turn on. But I didn't find that until I'd pulled almost all the parts off the board that I just put on, because I couldn't identify where the actual power supply problem was. I ended up taking off almost all the ICs, and then I ended up taking this radio on and off about 4 or 5 times. And I eventually got it to work off the board, and then I slowly put it back on by making single wire connections and figured out that it was a power supply issue. Pulled that tantalum cap off and we're good to go. Then I ended up putting everything back on the board. And it's able to program over the serial port, and that's a good thing. So that pretty much wraps it up for this evening. Tomorrow I'm going to continue to put parts on the board. I'm going to put on the A/D converters and start writing software to actually exercise all the I2C as well as all the SPI components. So this is the SolOhm update for February 18th, 2016. Thanks for watching.